Okay, hi everyone. Welcome to our February student body meeting. Let's go ahead and get started.
Welcome. Before we get started, please make sure that your Zoom name is renamed to your first name, last name, and your grade level.
We'll give you a few seconds to do that. All right, moving on. So here is our student of the month. It is Ashley Arnold. Not only is she an active academic student, but she's also heavily involved in sports. She plays soccer and volleyball and has lettered in both. She's passionate about engineering and hopes to pursue it in the future. And her peers know that she is driven in whatever she puts her mind to, and she will always remain a ray of kindness. So make sure to nominate our next student of the month on our Elkins Engineers website.
Now, regarding volunteering and enrichment, as of now, the spring semester will require 12 and a half volunteering hours, and it will be required just like normal. By the end of the school year, each class should have at least for freshmen 18 and a half hours. For sophomores, is 31 hours. For juniors, is 56 hours. And for seniors, is 81 hours. And all this is required for academy distinction at graduation. Now, the instructions are posted on our Remind and student websites for how to submit hours.
So continued on the volunteering and enrichment, remember 2 enrichment activities are required for this semester like normal, same as last semester. Make sure to submit your enrichment activities into the Engineering Academy Schoology page and fill out the attached enrichment form. For all enrichment events, except for student body meetings, you do not need to attach a photo, but you do need to explain what you learned and everything at that student body meeting. Remember that the deadlines and requirements are always subject to change, so please make sure that you are on our Remind and are looking at Mr. Lambs's weekly newsletters.
Seniors, please read this message from Mr. Lamb, and also we sent this through student email. Your yes hours have been updated on Schoology. Please check your yes hours and note that your count of yes hours will be listed as the grade for total community service hours assignment in your Engineering Academy Schoology course. Make sure that you are on track and have 81 hours by the end of April. And there are virtual volunteering opportunities in Mr. Lamb's weekly newsletter. If you have any questions about your yes hours, please contact Miss Sands at the given email, and do not wait till the last minute to do this. Now, regarding house points, the competition is getting kind of close. Encourage your friends in your house to come to events, and the house with the most points at the end of the year wins the reward. So last month, as y'all can see, Tesla is in the lead. And this month, again, Tesla's in the lead. Y'all, I'm gonna need y'all to kind of step it up because Tesla's going to win.
So now moving on to our winter semester raffle. If you earned at least 14 points last semester, you're going to be entered into a raffle for three people will win, and each winner will get a $10 gift card. So let's move on to that raffle right now. If you win, please make sure to put in the chat your email so that I can give you that gift card. So let's get started with the first winner. All right, Ilian, if you are here, please make sure to chat to me. If you are not here, then we are going to move on to the next person and you will not get that $10 gift card. So please make sure to message me or email right away. Moving on, I will check to see if he gives me his email. So let's move on. Same thing with Adam M in 9th grade. Please make sure to give me your email. If not, if you are not here, then we are going to move on to the next person. All right, let's do this again. Again, Srinivasa M in 10th grade, please chat me your email. And I'm going to check my chat right now to see if, okay, Adam, you have claimed your prize. Congratulations. And I am waiting a few seconds for Srinivasa and Ilian. If not, we are going to keep going. I'll give them a few seconds. Okay, it doesn't seem that those two have claimed their prizes, so we are going to continue. Okay, Nevin, if you are here, please claim your prize. And we're going to spin again. And Nevin has claimed his prize, so there is one more person, and please make sure to chat me your email, your personal email, and one more person. Okay, Adam has already claimed his prize, so we have to spin again. Okay, Ahmed H in 12th grade. If you are here, please chat me your email and I will, okay, great, awesome. We have already chosen our three. They are Adam, Nevin, and Ahmed. Nevin, please chat me your email just so that I have your email. And awesome, thank you guys for claiming your prizes. And I hope this will motivate all of you guys to come to our events and be entered into more raffles like this.
Okay, now follow our Instagram. We post important information such as student body dates, monthly agendas, giveaways, and more. The Instagram is at Elkins Engineers. We don't spam, we promise. If y'all just want to take a picture of that, go ahead.
And Mr. Lamb's newsletter, please make sure to check out his newsletter as there are many updates and he gives very helpful information. It is sent to your student email each week, and there are virtual volunteering opportunities, virtual enrichment opportunities, academy updates, and promotion of various scholarships that you guys can apply to. So please make sure to check his newsletters weekly. And introducing Ayush Sharma. He's a chemical engineer at Sasol Chemicals, so he is going to be our speaker today. So let's introduce him, and without further ado, go ahead and I will stop sharing my screen so you're able to do that.
All right, how's that look?
Yes, it looks perfect.
All right. Hi, everyone. My name is Ayush Sharma. I'm a chemical engineer, and I'll just be talking to y'all a little bit about chemical engineering and hopefully motivate y'all to become a chemical engineer in the future. So for our agenda, we're first going to talk just a little bit about me, my background, then I'm going to discuss what exactly is chemical engineering, go into a little bit about the coursework. So I graduated from UT, so I'll be focusing on the coursework there, and then talk a little bit about my company, Sasol Chemicals. So about me, I'm from Sugar Land as well. I graduated from Dulles High School in 2014. I had the opportunity to be in the Math and Science Academy inaugural class, and that actually had a huge impact on me deciding to become a chemical engineer. I graduated from the University of Texas at Austin in fall of 2017 with a bachelor's in chemical engineering, and I'm currently working as an R&D chemist at Sasol Chemicals from February 2018 to present. So to start off, what is chemical engineering? Because when I first applied to be a chemical engineer, I really didn't know too much. I knew I enjoyed chemistry, and I knew, or I thought at least I enjoyed engineering. So I thought maybe this would be perfect for me. So what chemical engineering is it's really an interdisciplinary study involving all these subjects: chemistry, physics, math, and even biology. So if you like to do math, if you like to see how that can combine with chemistry and physics, especially, then chemical engineering is a perfect field for you. As a chemical engineer, your goal is to develop chemical processes to convert raw material into products. And this can be in a multitude of fields. So, but the general case and everything, we're taking raw materials and converting them into something else. As a chemical engineer, you'll design, optimize, and control chemical processes. These first you would have to design them, of course, and then you want to make them as best as possible, and you want to have control over what sort of products you're making. So this applies to a whole bunch of fields. The biggest two for chemical engineers that we work in are petrochemicals and energy. So petrochemicals would be anything taking petroleum out of the ground, converting it into chemicals, which is primarily what my company does. Energy, in like the oil and gas field, there's lots of chemical engineering opportunities there. But there are lots and lots of other fields that chemical engineers work in. For example, pharmaceuticals. They're also, converting these raw materials into medicine. Polymers, such as, shopping bags, things you use on a daily basis, were designed by chemical engineers. Microelectronics, so this would be more on like silicone chips. That's a big field for chemical engineers. Biomedical devices, for example, prosthetics, these sort of things, like stents and stuff that go in your blood vessels could be designed by chemical engineers. Fertilizers, food industry, all of these are areas where chemical engineers can work and can have some influence. So I'm just going to go over a few of the courses at UT to kind of see, and this gives you a good explanation of all the different fields that chemical engineers can work in. So on this slide, this is all sort of mandatory courses. I'm only going to be focusing on UT's syllabus because that's where I went, but you'll see most schools are very similar to this. So of course, as a chemical engineer, you'll have to know some chemistry, general chemistry, organic chemistry, and physical chemistry. So these are kind of the main chemistries that you have to take. Organic chemistry will be about organic molecules, so anything carbon-based and stuff like that. Physical chemistry is about how physics and chemistry interact with each other. So it's sort of on a atomic scale or molecular scale how things work. Engineering physics, of course, that's one of the intro classes you'll have to take, because chemical engineering has a lot to do about physics. A lot of it is about how this is going to sound boring, but how fluids flow through pipes, and that is a lot of physics. I do recommend, if you have the opportunity, try to AP out of physics, because it's a very difficult class in college. But it's, if you want to be an engineer, it's something you'll have to take. After that, differential equations. Differential equations is I'm guessing y'all will probably take calculus in high school. But after that, differential equations is just an advanced math class, which tells you about just math. You'll find out when you take it. Some other courses that are more on the engineering side, computing and numerical systems. So this is something more newer in chemical engineering. It's if you've done Java, at UT at least, the program we used was called MATLAB, which is something you code in, and you can replicate systems in chemical engineers in this computer program, and see, you can make models, you can do things like that to see if you change this, how will this affect the affect your process. Applied statistics, it's another engineering course. Statistics not as important in chemical engineering, but definitely is. Communications is all about, as an engineer, how do you write, how do you talk, how do you discuss with other people, which is definitely very important in any field as an adult, but it's important for engineering. And on this right side, what we have are the actual chemical engineering courses. And hopefully, as I go through these, you'll have a little bit of understanding of what a chemical engineer means. So transport phenomena, it's the basis of chemical engineering is really two things: heat transfer and mass transfer. So as you can imagine, flowing something through a pipe or flowing something into a reactor or trying to separate it, you're going to have mass, right? Mass goes in, mass comes out, as well as there's going to be heat. You're either heating it or cooling it down, so you're going to have heat transfer. So transport phenomenon is all about mass and heat transfer, which is really the crux of chemical engineering. That's really the most important thing, I would say. Next, thermodynamics. It's more of heat transfer from a physics point of view. How does that work? Materials is a really interesting class because you're looking at how atoms orient in three-dimensional space and how that affects the materials, the property of the materials. That's a really interesting class, especially if you like to visualize things in 3D space. Unit operations is about the actual instrumentation and machinery that gets used at a chemical plant. So it's about like valves and how valves work and how pipes work and all this kind of thing. So that's a really important class if you want to be a chemical engineer. Process control, which was one of my favorite classes, is about how you control a process. It's really in the name, but if you can imagine, if you have some sort of chemical reaction going on, you want to keep track of the temperature, keep track of the pressure, keep track of your flows and things like that. And that's it's all computerized nowadays. Before, they actually had to control it with manual valves, but now it's all computerized. And you learn about how these computers control these processes, which I found really interesting. Separations is basically, let's say in your chemical plant, you make some product, but then you also have byproducts, and you have different things in that pot, and you need to separate it all out. So it's about how you separate out chemicals from each other. Reactor design is about actually designing reactors. So there are different types of reactors based on what your application is and what you're trying to do. So if you want to have a certain reactor, it might be flow through, meaning it's continuously going in, and out. Or you could have what's called a batch reactor, where you put everything in a pot, you do the reaction, and you get stuff comes out at the end. And that's what reactor design about. And process design, that's the last course you'll take in chemical engineering, where it's also called senior design, because basically you have this plant that you have to design from start to finish. You have to do everything in that. So what kind of equipment do you want to put in it? What kind of how do you want to make things flow? How do you want to do this and that? How do you want to control it? So all of this is basically like your senior. You can think of like a senior thesis. So everything you've learned previously, let's apply it and see if you can design your own plant. So these are all like mandatory courses that's required for the for the degree. But this is like the core chemical engineering classes. There's also lots of optional classes, electives and that kind of stuff. And there's lots in chemical engineering. There's lots of area for further study, because out of all the engineerings, I would say it's the most vast. It has the most you have the most options to go into really any other kind of field. You have different kinds of chemistries you can further study. Inorganic, so that would be like about how metals and things like that. Analytic chemistry, so that's about analysis, straightforward. Quantum chemistry is more on the physics side, about how molecules and atoms interact with each other on a very, very, very small scale. Polymer chemistry, that's a huge field, because everything, not everything, but lots of things around us are made of polymers nowadays. And that's a really big field in chemical engineering. A couple other kind of different ways of thinking: environmental design, which is, at any chemical plant, you're going to have off gases, you're going to have things coming out of your reactions that might not be the best for the environment. So how do you account for those things, and how do you deal with legislation and things like that? Process safety, that class is all about the chemical plant is a very dangerous place, and how to make sure that at the end of the day, all your employees are safe and things like that. That's what process safety is. This next one's kind of similar to environmental design. It's air and water pollution and treatment, which it's exactly what it says. You don't want to let off too many chemicals into the water and air, and if you do, you want to be able to treat it. So that's what that class is about. Engineering economics, that's more on like the business end, if that's your forte. That's definitely a very important thing in chemical engineering, if that's sort of the side you want to go to. Some other classes, so biochemical engineering is really big, which is basically how, because our body is also a chemical process, right? So learning about how our cells work, how the chemical processes within our cells work, which is interesting. Cell and tissue engineering, sort of in line with biochemical or biomedical engineering even. Engineering biomaterials, this is all about like prosthetics and things like that, and how that ties into chemical engineering. Photovoltaics, this is a totally different side. So these next few are about energy. So photovoltaics is about solar cells and things like that, which it's a very, if you're interested in that, it's a very cutting edge, new kind of developing field. Energy, technology, and policy, which are, about, because chemical engineering is so, it deals a lot with energy. So whether that be oil or gas or renewable energy, there's a lot to do there. And last, what I think was one of the most helpful parts about undergrad was undergrad research. So what you'll find out is that most of the professors that wherever you go to school, they have, they do research themselves, right? And they have graduate students who do research with them. So if you talk to your professor, you're able to, do undergrad research, which gives you a better idea of maybe where you want to go in the future, and just give you, especially if you want to go to grad school, it gives you some experience working in the lab. So that's all about school. Now I'm going to talk a little bit about my company and what we do. So Sasol Chemicals, we're a leader in surfactant chemistry and petrochemical manufacturing. We'll talk a little bit more about what surfactant chemistry is, but basically everything you see on this slide are products that we sell into. As a surfactant, you can think anything that cleans is a surfactant. And we manufacture all of those from from petroleum-based products, and we sell then to all these companies like P&G and Arm & Hammer, who then go and make all of these products. Sasol has the largest portfolio of unique alcohols, alkoxylates, and specialty chemicals. These are just various types of surfactants that get used in different industries. And all these chemicals have applications in detergents and cleaners. So that could be, laundry detergent, dishwasher detergent, hand soap, anything like that. Personal care and cosmetics, so that would be more shampoos, lotions, that kind of thing. Paints, paints is also really a big chemical engineering field, because whatever you want to put on the wall, the color, the consistency, and you want it to dry in a certain time. So that's all part of engineering, and we sell chemicals into that. metalworking and lubricants. You can imagine like machinery needs lubrication for all the metal to work together to make sure it doesn't corrode or anything like that. So we sell into that. Oil and gas. So we also sell chemicals to the oil and gas companies to basically recover their oil better. Well, that's called enhanced oil recovery, which is like basically you can imagine if a company sets up a big drilling operation, they want to get as much out of it as possible. So we sell chemicals into that field so that can get more bang for their buck. And agricultural applications as well. For example, some of these alcohols are sprayed on plants as pesticides, herbicides, insecticides, that kind of thing. So we really sell into almost all fields that you can imagine. Next, I have a little video from YouTube to show our plant. So it's only about a minute long. So just to give you really quick, so this is where I work. This is the R&D buildings. And then basically all of this area is our chemical plants. And by the way, I don't think I mentioned this. I live in Lake Charles, Louisiana. So if you're driving east on I-10, it's one of the first cities you hit in Louisiana. And this is kind of what you'll see from I-10. So yeah, that's our Lake Charles chemical complex here in Louisiana. We have a total of 14 different plants in that complex where we make a whole slew of different chemicals. And what's great is working in R&D, I have the opportunity to do lab work, but I also, being a chemical engineer, I go out in the plant quite often and communicate problems with them and try to solve problems with them. So our Sasol production sites, we're really all over the world. It's a South African company, so that's where they have their biggest operations. In South Africa, they actually have a whole city called Sasolburg, where they have a school, they have hospitals, they have police officers, all this kind of stuff, which is really cool. But in the US, we have operations in Lake Charles, we have operations in Germany, Italy, and we have some new plants in China as well. Just some applications. Now, this is another unique one that we got an email for a couple weeks ago, that one of our chemicals is actually used in the Pfizer COVID-19 vaccine. So this molecule right here is the lipid, which encompasses, so if this is the mRNA for the actual vaccine, and you have to have a lipid around it to encompass it. This is kind of, if you remember from biology, this is how viruses work themselves. They have a lipid coating. And this, what's highlighted in yellow, is a chemical that we sell, which then Pfizer or some other company reacted to make this molecule, which is then used as the lipid coating of the vaccine. So the chemicals we sell really go into every field that you can't even imagine. I want to just briefly touch on what is a surfactant, because I've said that a few times. So surfactant is a surface active agent. It has water loving, so hydrophilic, and oil loving, so hydrophobic components in the same molecule. So if you can imagine, if you have oil on your hands, you can't just wash it off with water, right? Because water water and oil don't mix. But using these surfactants, which is what we sell, you're able to emulsify fats in water. So basically, these are two very common surfactants. If you look on the back of your shampoo bottle, you'll probably see one of these. So sodium lauryl and sodium lauryl sulfate. Basically, this end, if you remember from chemistry, like dissolves like, right? So this end is polar. So this end gets dissolved by the water, and this end is non-polar, right? This is just carbons and hydrogens. So the non-polar end dissolves the oil, the polar end dissolves in the water, and you can wash oil off your hands, basically. A few things about what I do as a R&D chemist. So first, this I just wanted to show this. If you work fully as a chemical engineer, this is sort of what you're going to be looking at on a day-to-day basis. So this is what's called a piping and instrumentation diagram. It's basically you before you make the plant, you have to come up with designs, right? So this shows exactly how the parts of the plant interact and how you control those different things. So in this case, you have a feed coming in, it gets heated in this heater, it goes into this, what's called a distillation tower, because out of, you have something coming out the top and you have something coming out the bottom. So this is a basic part of chemical engineering, which is separations. And as a chemical engineer, you would have to look at this, you would be like, okay, maybe your tower isn't working as you want it to. So you would be like, okay, we have how can we change it? We have temperature control. This is how you would adjust the temperature, or you can adjust the flow over here. You have all these different knobs to turn, and that's what a chemical engineer you would do. But yeah, so I do some of that, but primarily my job is in the lab. So I perform lab scale experiments to develop a new product. So this tower, you saw in those videos, they had really tall towers. This would be about 200 to 300 feet. In the lab, we have a 4-foot distillation tower that we can work with. I diagnose and resolve issues with product quality. So if the products they're making aren't up to the specifications that they need to be, that like the customer wants from us, then they'll come to us and they'll be like, hey, this isn't working, what are your ideas? How can we fix this? And we'll go into lab, we'll do some experiments and give them an answer. We optimize individual reactors in the process. So, the reactor might not be working as you want it to. So they'll come to us, the same concept where in that video we have reactors that can handle thousands of liters at a time. We scale that down in the lab, and we have tiny reactors, 300 milliliters. We have a liter reactor. We have a 5-gallon reactor. So we're able to scale down the problems of the plant onto a lab scale, and then communicate what we think will help them back to them. We monitor process conditions to ensure plant health, just make sure things are flowing as they should, and provide suggestions to improve the operation of the plant. So on a day-to-day basis, that's kind of what I do. Have problems come in from the plant, talk to these other chemical engineers, see what they think we should do some experiments in the lab, and then give my suggestions back to the plant. So that's all I had to present. Thank you all for coming, and we can do questions now.
Okay, if you have a question, please put them in the chat, which will go directly to me, and I will moderate those questions. So starting off, we have one. Out of all the courses you took at UT, which one would you say is the hardest?
Okay, yeah, that's a good question. I would definitely say the hardest class at the end of the day was process design. So that's our senior design class that we have to do for a couple of reasons. First of all, you're taking everything you learned over the past years and you're combining it into a single project. So that takes a lot of effort. Plus, it's a group project. It was in groups of 4. So, you know, working with other people sometimes can be troubling. When they have their own classes, you have your own classes, all this stuff going on. It was definitely a difficult thing to do because we really had to design the entire plant from the bottom up. We had to talk about the economics of it. We had to talk about the supply and demand factor, why we chose this process, all that stuff, and then we had to put out a report over all of that. So it was definitely a very interesting class, definitely a good way to learn, but definitely also a difficult class.
Okay, so we have another question. Did you ever want to be anything other than a chemical engineer, or did you ever think about pursuing another major while you were at UT?
Yeah, no, for sure. I was actually pre-med, you know, as since you know, all Indian people are really pre-med. My parents wanted me a doctor, but at the end, I'm like, hey, that's not really what I want to do. So I figured this was a better course of action. So even through while taking these chemical engineering courses, I did have to take a couple extra courses for being a pre-med. But at the end, I figured this is definitely closer to what I wanted to do.
Okay, so how advanced in biology do you need to be for chemical engineering?
How advanced in biology was that the question?
Yes.
It really depends on where you want to go. So if you want to focus on, because in chemical engineering, it's really so vast that if you don't want to be in biochemical side, you really don't have to. Based on your school, they might have some biology classes you have to take, but uh, guaranteed there are multiple paths set up where you can go into different fields and doesn't have to be biology based.
Okay, next question. What would you consider to be some hazards in your line of work, or like what you do day to day?
Okay, yeah, for sure. So the the chemicals that we work with can be hazardous themselves. Most of the things we work with, you can think soap, right? Soap's not really that dangerous, but when you're making the molecules to go into the soap, that's where some of the hazardous conditions can come up. Um, yeah, so the chemicals could be hazardous. The process conditions can also be hazardous because in the lab we'll be working in with reactors. You know, depending on your reaction, they can be hundreds or thousands of psi, which is like you think of your car tire. Your car tire is about 35 psi. So imagine something that's 1,000 psi. So it's very high pressure. If that reactor were to burst, it would, you know, send shrapnel everywhere. Um, Other than that, there's just you know, mistakes can happen, right? So for example, when we have to wear steel toe boots because if you drop something on your toes, you definitely don't want to hurt them. So that can happen. We've had fires in the lab from different reactions going, you know, not as planned. So you can always have fires. You can have chemical releases. But what's important is before we do anything, we have this sort of discussion where we're like, okay, what can happen here? How can we you know, work to prevent it? Because obviously at the end of the day, we don't want anyone to get hurt. So we make sure to have these detailed discussions about what exactly we're doing and, you know, what precautions are we taking. And, you know, a lot of times people have other ideas like, oh, maybe you should add this to make it a little bit safer. You should do this. So having that discussion makes it, you know, makes the whole environment a lot safer.
Yeah, that's definitely interesting that you have to wear steel-toed boots. Um, Another question is, has your job been affected by COVID-19? As in, do you still go into the lab or do you do a lot more online work?
Yeah, so it definitely has been affected. I'm at home right now, so it's really job dependent. For my group, what we've decided to limit the number of people on site is 1 week on site and 1 week working from home. So you know, whenever you're on site, you try to maximize the time when you're in the lab so that you can when you're off, you can work on like report writing and having meetings and that kind of stuff that doesn't necessarily, need to be in the lab. But at the same time, COVID vaccine or coronavirus has kind of been a boost in our industry in particular because we have a lot more sales of stuff that goes into hand sanitizers and stuff like that. So in a way, it's helped us as well.
Awesome. One more question. Do you collaborate with other engineers from different disciplines? And if so, what do you do when you collaborate with them?
Yeah, definitely. So I would say the biggest would be mechanical engineers because they're the ones because in chemical engineering, we do learn about how to design these reactors and design these kind of things. But mechanical engineers generally have a better understanding of like how much stress this reactor can take, how these things, if it were to burst, what sort of things you're be looking at. So mechanical engineers and chemical engineers work together, especially in designing new plants or in setting up pipes and reactors and that sort of thing. Other than that, that would probably be the most common discipline that we interact with.
Okay, that was our last question. If you guys have any last minute questions, put them in the chat and I'll give you guys a few seconds to do that. Okay, I don't think we have any more questions. So thank you so much to Mr. Ayush Sharma for coming and speaking to us. If you would stop sharing your screen, and then we will conclude our SBM.
All right, thank you all for having me.
Thank you. Okay.
All right, just a reminder to stay connected. Mr. Lam is the Academy coordinator. His email is there and his school phone number is right over there. Now, some important websites are the FBI's The Academy website. The link is over there. The student website and the Booster Club website. Now, we have our social media, our Instagram and our Twitter is both the same thing. And our YouTube is the Elkins Engineering Academy. We'll stay on this slide for a bit in case y'all want to take pictures. All right, so just an event review. Help us make our events better by reviewing and giving us comments. We'd really appreciate your help greatly. Now, again, the URL code is right there, and if you don't have it, just go ahead and type in the link. And y'all, please let us know how we're doing so we can make these student body meetings a lot better.
And you can quickly scan that QR code to give us that review. Okay, thank you so much for attending our student body meeting. We hope you enjoyed it. And again, thank you so much to Mr. Sharma for coming out and presenting about Sasol chemicals.
Are you able to hear me?
Yes,
we can hear you.
Okay. Thank you so much for coming and speaking to us, Ms. That was great. For the student, just want to remind you guys, some of you are emailing me telling me that, well, it's COVID, I can't volunteer. Okay, there are plenty of virtual volunteer opportunities in my newsletter every week since the beginning of this year. So make sure you take care of those volunteer hours and make sure you know where to submit them. It's also in the newsletter. I believe for one of the, there's a create a card volunteer opportunity to create a call for a hope kit. make sure you go to the newsletter and read instruction on that. There is an update instruction on where you need to turn in your volunteer hours to. Okay. And you have any questions, just email me, guys.
Okay, quick question here.
Go ahead, Andrew.
Okay, so yeah, so I got here about 20 minutes late because in the newsletter it said that our student body meeting was going to be at 4 o'clock today.
Oh, my apology. I thought I saw you log in a little earlier.
Well, I did. It's just that I went to go have some snack after my class and then didn't get back in time. So
that's all right.
I was thinking.
Okay. Okay, I appreciate. Let me know that.
All right. Thanks.
Okay, and there's
Mr. Lamb.
Yes.
So regarding the volunteer hours for seniors,
Mm-hmm.
when it shows on like Schoology, like total volunteer hours, it shows like X number out of 100. For seniors to have like 81 hours, is it going to be 81 out of 100 or 100 out of 100?
81 out of 100.
81?
Yeah, just remember, yeah, we didn't take it last spring. We reduced it this fall. So yeah, so that's why it's 81. So it's 19-hour kind of excuse for you guys due to COVID.
Okay, thank you.
Hey guys, just remember, I do not validate volunteer hours, okay? Because I don't go and approve volunteer hours. There's actually a group of parent volunteer that does that. That's why you have to turn it into, you have to turn your volunteer form to Miss Adams, and then she forwarded to these committees that they're the one who approve. And once a month, I get a updated list, and I try to update on Schoology. But if you're just curious, just send me an email, then I could tell you if I don't have time to update it. But I try to update it as fast as I can. Just right now, just juggling multiple things right now. So, but right now, your volunteer hour on Schoology should be updated. Be patient. Sometimes it does take a few weeks for them to, get your volunteer hours and go through it and approve it. If it doesn't update, you turn in something in December and you don't see it. If you don't see it again in February, then you need to let me know. All right, that's it. All right, hang in there, guys. We're almost there.
Mr. Lamb.
Yes.
So for this half of the semester, we only need how many more hours do we need for this half of the semester?
12 and a half.
12 and a half for this half of the semester?
Yeah, for the spring, you need 12 and a half hours. So this year total, you should have 18 and a half. And yeah, just remember for my freshmen, I know, just kind of give you some advice. Some of my upperclassmen kind of learn how to do this. And if you have opportunity to do volunteer hours in the summer, do it in the summer, and you will get 20. The max hour you get on summer is 25, but then you're done with it for the school year. Okay, so if you're doing 25 hours this summer, so you don't have to worry about for year of 2022, 21, and 22, you don't have to worry about your hours anymore. Okay, so try to look for opportunity in the summer to take care of this. All right, Genevieve, I'm done. Thank you.
Thank you, Mr. Lamb. If you guys have no other questions, you are welcome to leave. And again, thank you so much to you all for coming.
Just a quick reminder, guys, go get Mod Pizza on University this Thursday to support your booster club. They do support us in many things that we will be doing. So make sure you go out there, tell your parent. I send them an email this Thursday because there's a link you can order to go or pick up, and then they give 20% back to our booster club. Okay.
Mr. Lamb, I submitted to the 2 of the enrichment activities.
Mhm.
One got approved. I assume, like it said, I got 100 in the activity. I assume that's the way of them approving it.
Right.
So the first one I submitted, they approved in like a week. And then I submitted 2 more, one I think in November and one in December. So I have
Okay.
3 total, but none of the second or third ones are
Okay.
approved yet.
Do me a favor, send me an email and let me take a look into that.
Okay, yeah, sure.
Okay, thanks.